Hey, algebra friends. Today we are going to be talking about, we'll start with set builder notation. So the way you read this, when you see something like this, when you see the little squiggly brackets, you're going to say the set of. And then here you're going to say all x, or if it was a different letter, all whatever letter. This line, or it can be a semicolon, you'll say such that, and then you'll read the inequality depending on what sign it has. So this reads, set of all x such that x is greater than 0. All right, so let's practice a couple of these. First, let's do this one where we kind of just take this exact thing and put it in there. So the squiggly bracket, we're going to write the set of for the squiggly bracket. Our letter here is y, so we're going to write the set of all y. That line or semicolon, we're going to say such that. And then we look at our inequality. Y has to be greater than or equal to -4. Now, if you aren't sure, when you look at an inequality, if you can't remember, is that the greater than or the less than symbol, or which one is it? I have this little hand hack that I do. You know, like if you forget your right from your left, you can hold up your hands, and the hand that makes the L is your left hand. I'm sorry, it's reversed on the camera. But you can do the same thing for inequalities. You can hold up your hands, and the hand that makes the L is your less than symbol. As long as your variable comes first, then that is going to be your less than symbol. So that's how sometimes I remember them in my brain. If I looked at this one here, that doesn't make an L, so I know that's a greater than symbol. Same thing here, that's a greater than symbol. If it goes the other way, though, it would be less than. And then, of course, if it has the line underneath it, then that means or equal to. If it doesn't have the line, then it can't equal that number. All right, so now let's go in reverse here. And I'm going to go ahead and write this because I think it's easier to write than to type. So the set of all m such that m is less than or equal to 3. So we know we need our squiggly brackets. I cannot draw those. We know our letter is m, the set of all m such that m is less than or equal to 3. So I'm going to hold up my hands. I'm going to get my L, and I'm going to say, okay, I know my symbol has to go this way for less than because it's equal to, it needs a line underneath it. And then I'm putting the number 3 there. Whoa, that's a funky looking 3. And then we finish out with our squiggly brackets. I'm sure that has a better name than squiggly brackets, but that's what I'm going to call them. All right, so that's how you would write that. During this lesson, we're also going to be talking about the important keywords or and. Now, if you have two different things and both have to be true, then you're looking for the intersection where both of them intersect. If you have two different things and either one or the other could be true, then they could both be true. It's going to be one or the other. It doesn't have to be the intersection. It would just be both of them separately. Okay, we're going to speak a lot more about this, but if you see or, it can be one or the other, so both of the solution sets are going to stay there. If you see and, it has to be both, so wherever they intersect is going to be your solution. So let's look at some examples of that. It says, what is the solution set of x plus 4 is greater than or equal to 10 and 2x minus 5 is greater than or equal to 7? So it gives us a hint here. It says solve each one separately. So let's go ahead and do that. X plus 4 is greater than or equal to 10. Remember, when you have inequalities, you solve them just like equations. For some of you, it might be helpful to draw your line or your balance beam down the equation to remind you to keep it balanced on both sides. Some of you might not need to do that anymore. Solve it however you know how to solve equations. But we know when we solve equations, we are trying to get the x by itself. We're trying to isolate the variable. So we have to get rid of plus 4. The opposite of adding 4 is subtracting 4, so we will do that to both sides. 4 minus 4 is 0. We're going to bring that x straight down. We're going to bring our inequality symbol down, and 10 minus 4 is 6. Remember from last year, the only time that you ever change that inequality symbol is if you multiply or divide by a negative number on both sides. If you're dividing each side by a negative number or multiplying each side by a negative number, you have to flip that symbol. Every other time, the inequality symbol is going to stay the same. So our our solution for our first equation is that x has to be greater than or equal to 6. So if you did this on a number line, because it has the equal to line, we know that that's a closed circle. It can equal 6. And then for the numbers greater than, that would all be to the right. And you could, of course, plug in a number on each side to see which one is true, but this is how you would graph it. All the numbers greater than or equal to 6 are part of your solution set. Now we also need to do the second equation. We got two things happening here. So 2x minus 5 is greater than or equal to 7. Again, we're going to go ahead and solve this equation. So I'm going to add 5 to both sides. Bring my 2x straight down. I don't need to flip my symbol because I did not multiply or divide by a negative. And then we're not quite done. We still haven't got x by itself. We still need to divide each side by 2. Do I need to flip my symbol? Did I multiply or divide by a negative? No, I'm divided by a positive 2, so my symbol stays the same. You only flip it if you multiply or divide both sides by a negative. So look at this. This one is also that x has to be greater than or equal to 6. So that's a closed circle shaded to the right. In this case, this is kind of a cool situation where they're both the exact same. And so it has to satisfy both because it has the word and. Since they're both the exact same, this will satisfy both. You can rewrite that, though, in that set builder notation that we just talked about. So you could write this as the set of all x such that, I'm going to use semicolons for such that this time, just so that you know that that's okay too. You'll see that too. Such that x is greater than or equal, whoops, I need that equal to line, 6. Close your brackets. So you could write it like that as well. All right, let's try another example. So now we want to know what is the solution set of 5x minus 1 equals 9 and 7x plus 4 is greater than negative 3. We're going to solve these separately. So let's start with 5x minus 1 equals 9. We're going to add 1 to both sides. 5x equals 10. Then we'll divide by 5 on each side. If I'm solving these equations way too fast and you're like, ooh, I need way more help with equations or inequalities, we can do that. Come to Live Help Time, send us a text or a webmail, let us know that you need more help with these, and we will go through them slower. But for the sake of this video, I am going to be moving pretty quickly through these equations and inequalities. All right, so we're going to subtract 4 from each side. Bring my 7x straight down. I do not need to flip my symbol because I'm subtracting. Divide each side by 7. Now this confuses a lot of people. They're like, oh look, I'm dividing and I'm getting a negative number. Do I need to flip my symbol? No, you're dividing each side by a positive 7, so you do not flip your inequality. If this had been a negative 7 and you were doing that to both sides, then yes, you would flip your inequality, but you're not flipping it here. So the first solution says x has to equal 2. The second solution says x has to be greater than negative 1. And if we graph that, just so you know what it would look like, let's get a negative 1, a 0, a 1, and a 2 on there. Greater than doesn't have the equal to line, so that would be an open circle. An open circle means that it is not equal to negative 1. Negative 1 is not a solution. And it's greater than, so we're shading everything to the right. So every number to the right or greater than negative 1 is a solution. 0 is a solution, 1 is a solution, 2 is a solution, 1 million is a solution, right? Everything greater than that. But because it says and, it has to be true for this one and this one. So the only value that's true for this equation and this equation is the value of 2, right? Because x can either equal 2 or it has to be greater than negative 1. So when we write this, the only possible answer for both of them is the number 2. So that is our full solution set. Since it has to work for both equations, that's the only one that works. All right, let's jump over here to this one. We're going to solve each of these equations separately, and for time's sake, I'm going to pause this video and solve them. All right, I've got them both solved. For this green equation, I got x equals -3, and for the second one, I got x equals 5. This is an or problem, and I should, you know what, I'm going to go back and I'm going to write that in here. This is or, this is and. Oops, that didn't change colors. Sometimes you will see the solutions left as this, right? That is okay. You can leave solutions like that, x equals -3 or x equals 5. That can also be written in that set builder notation. It can be -3 or it can be 5. Either one of those work. Over here, the only answer that worked for both was 2 because it was an and problem. But for or, you can keep them both. Okay, let's keep going. So we have another or problem. This time it's 2 inequalities. So let's go ahead and solve each inequality separately. 3x plus 4 is greater than 10. And 2x minus 5 is less than or equal to -7. I'm going to go ahead and add 5 to each side. Bring my 2x down. I don't need to flip the symbol when I add. And then I'm going to divide each side by +2. I don't need to flip my symbol when I divide by a positive. So that's my solution for the green equation. X is less than or equal to -1. And then I'm going to solve my red equation. I'm going to subtract 4 from each side. I do not need to flip the inequality for subtracting. Divide by 3 from each side. I do not need to flip when I divide by a positive. So my solution here is x is greater than 2. Let's go ahead and graph each of those. And you can graph them on separate number lines, but I'm going to graph them both on the same number line. Oh, and I'm going to add my word or in here. That's really important because that word makes all the difference. All right, so I'm going to need -1, 0, 1, 2. That's really all I need. But I'll put a couple more numbers on there just for kicks and giggles. Okay, so for the red one, it has to be an open circle at the number 2 because it doesn't have the equal to line and it's greater than, so we're shading to the right. For the green one, it has to be a closed circle at -1 because it has the equal to line and we're shading to the left. It can be over here, the solution set, or over here. That is what your graph will look like. You're going to leave them both separately, right? It can be one or the other. So that is how it is going to look. And when it says determine the solution set, we can just leave our answer as this. X is greater than 2 or x is less than or equal to -1. All right, let's go ahead and practice matching these. Let me see. Yeah, okay, this is the last thing. So we have some of these, we have and statements. I'm going to go ahead and kind of put my and statements over here. And then we have some or statements. I'm going to put my or statements kind of over here. I just like to get myself pre-organized before I start solving. And then we have this guy in set builder notation. He's kind of totally different. Actually, let's start with this set builder. Set of all x such that x is less than or equal to 5. So we know we're going to need a closed circle on 5, and we know it's got to be less than. So if you look, you can click on them to make them bigger, but this one has a closed circle on 5 and all the numbers shaded less than. So that is going to go with this one. Okay. And now if you look at these graphs, I know they're tiny, but I hope that you notice that 2 of them are shaded just in one spot, and 2 of them are shaded in 2 spots. That's the difference between the word and or. Remember, and is where they both have to be true, and or is where it can be one or the other. So I know that these are or problems. If I look at this one, it says x is less than 2. That needs to be an open circle on 2 and an open circle on 5. That's a closed circle on 2. So that's going to go with this one. This has an open circle on 2 and 5, so that's going to go there. Then for these two, we know that they're and statements, so it has to be these. I'm going to look again at the circles. This one says open circle on 2 and a closed circle on 5. Open on 2, closed on 5. That's looking pretty good. This one says that it has to be a closed circle on both of them. So this one is going to go over here and this one over there. That's really all the time we have for today. If you have more questions, come to Live Help Time or get with your teacher. Bye.